So while we do the next wonderful session, I'm just doing, I couldn't get the GBIF one to work on our records, and I couldn't get Bold Digger to work because Bold shouted at me for asking too many times via the API, so it stopped. Yay! Yeah, it's maybe it's just something they've put in there to stop all of us. But what I'm doing is I'm just running the IDs through Bold, but I have to do them 50 at a time. So I'm just copying from the FASTA file against all barcode records on Bold. I'm saying email me the results. And I'm going to say submit another request. And I'll do the last ones. So from 201 to those ones against all barcode records. So this is what, there should be about 15 in here because I think we've got 115 or so. I'm going to say not email me the results. And I'm just going to say submit. And we'll see what happens there. While that's running, I just wanted to show you the two leeches we sequenced. So I copied the two sequences exactly like I've just done, and I ran them against Bold, and we got two species level matches, which is great. 99.69% match to that species and that species. The top one, I'm told, we absolutely 100% agree because the person who loaded that record onto GenBank and identified the species, it is matched against his sequence. So, wah! Gold star for that one. The second one, however, led us on a bit of a chase. So this first one, for example, it's matched this published record, which has been sucked in from GenBank, but you uploaded it to GenBank. You're happy that that's the right name. Excellent. The other matches are much lower. But interesting, look, that species is only once in Bold, right? So we need to get more in there. If we look at the second one, it's got a 99.69% match to tessellatum. Hang on. Plug my computer back in. Try not to electrocute myself. No, that's not going to work. Okay. But if we look at these, early release, private, published, but that's a different species name over there. We went and said, okay, well, it's published. Let's go find the data for that. Went on a little wild goose chase. It was a GenBank record from 2016. Went to the original paper. There's no data about where the specimen came from. So that's great. So we're like, oh, well, let's keep looking. And they're mostly tessellatum. And then here's another one, palins. Click, same story, basically. So all this data that's been sucked in from GenBank, very little common metadata standards, almost impossible to track down the information. However, with modern AI, and things like that, it'll solve all our problems, won't it? But I mean, GBIF does a really cool thing where they cluster records on GBIF. So there's two records on GBIF. They think they come from the same thing. They cluster them and they tell you. So maybe we could use that sort of approach to gather additional data because these records might have specimen records via a museum somewhere that's now on GBIF. Yeah? But that's a talk for another day. And here we can see actually that one tessellatum record that it matched in GBIF, in GenBank, and there is the entirety of the metadata, which is non-existent. Anyway.
What happens when you click on taxon? If that's the only submission, we kind of just see what the taxon is.
On taxon, you mean on organism? Yeah.
For example, or the taxon.
Oh yeah. So there are 72 nucleotide records. So there's a complete mitochondrial genome. That's nice. There's a whole bunch of RNA. Then lots of COX-1, yeah? But none of those are in Bold. This one here, new, negative. Yeah. So it just reiterates the value of putting in the effort when we're building reference libraries at the very beginning to make sure that your IDs are correct and your metadata standards are good, so that years from now we're not still suffering with these same problems. Yeah. But we need to incentivize that somehow. But that's someone else's, I can't figure out how to do that. So, yeah. Cool. And I ran it through the GBIF match, and because it was only 2, it worked. And the bold one, and this is only 15 records we're searching, and it's still going, still going. So that's why Bold Digger, at least you can walk away, and it'll download it for you when it's not crashing. Cool. So on to, we'll just let that carry on. And we'll go on to taxonomy and photographs. Slight change in actually what I'm going to talk about. I'll talk a little bit about photographs. I think we've covered a lot of the issues around taxonomy, but what I'll touch on is some work we're doing around reference library curation, just to dive into some of those issues. Yeah. I think we know the importance of photos. It really helps check for sample mis-ID quite quickly. You like, Joanna, that's a beetle, but the picture's a fly. What's going on here? You know, but at that quite high level. Of course, AI is going to solve all of our problems. And Rudolf and Amrita, their team is doing some ridiculously incredible work where they are combining the sequencing and the imaging, and then using the sequencing to cluster, and then using that to train the machine learning, so that, because as cheap as sequencing is, and it's essentially free now at the scales we're working, everyone's got one of these, and photos are free. So we will be in the future using images, and I think the DNA is the pathway to get to the images, basically. It can be fast, it can be slow, it could be diagnostic images. We don't do that for UK Bowl because we have the vouchers. So if you really want to come check an ID, we can send you a loan, take more pictures, whatever. So we just do the basic images. You can do single images. You can do focus stacking images. So this is something, again, from Rudolf and Amrita's group, the entomoscope, which is snazzy, I'll say. Advantages to having this, because you buy all the parts, it's relatively cheap, you get really nice images and things like that. There are ways of doing this with a commercial camera as well. So it's really just, I spend all my spare money on photography, so, but I might buy one of those anyway. And of course, you could do the ultra high throughput approach that iBowl does, where they use a digital microscope like this. Other models do exist. And the plate goes in there. The specimens are plated from a Malaise trap, for example, and then the microscope takes pictures of every individual well, stacks them and all that, and you have tens of thousands of images being generated a day. But for each insect in the well, it takes a stack and then combines them all. Yeah. But the problem is with that is, I mean, if they're small Diptera, for example, from a Malaise trap, they're all probably sitting on their sides, and that's a nice photo. But if it's a big bumblebee, it's probably on its head or on its ass, you know, and so you don't really get a good photo. Yeah. But at the scale that they're working, like 20,000 extractions a day, that's the only way you can keep up with the images. Yeah. Some comments around how to upload photos to Bold. Again, instructions in the handbook. My only comments really are just name your images intelligently, if that's a word, and consistently. That will really help you in the future. So as an example, we would name our images with the catalog number, which is also the specimen identifier in Bold, followed by an underscore, followed by the view of that image, which is lateral. In the case, sometimes we take dorsal and lateral. Bold asks you to take multiple images if possible. And that really helps with downstream processing of those image files and getting that data into the Bold template. Someone's going to shout at me for this, but one of the issues with upload to Bold is it has a maximum file size. When you upload the images, you zip them into a folder and it uploads 190 megabytes. If you have a camera, I mean, I think this phone is still like 10 megabytes a picture or something stupid. That's not a lot of photos that you can upload at once. However, everyone's insistent on saving things at like 100% quality in JPEG format. But if you save it at 90% JPEG format, you get 90% of the quality. You get a massive reduction in file size, but if you actually look at those two images, I guarantee you wouldn't be able to tell me which one was 90% and which one was 100%, even if we stuck them up on here and zoomed right into the pixels. You won't be able to tell. And so I would recommend that you either resize your images, that's the worst, probably the least likely thing you want to do, or just save them at a lower quality in JPEG and upload them. Otherwise, you can spend your life uploading batches of 20 images to Bold, which is just nuts. Maybe Bold 5 will have a better way of doing this, I think. Yeah. So then discount all of that. A trick I have for generating a list of images in a folder is you use that. I'm a terrible bioinformatician. I almost deleted my computer the other day by typing an RM command in with a wildcard. You know what that means. It's like remove, RM remove. And if you type asterisk, it does remove everything. Anyway, don't do that. Anyway, that'll just create a file list. There are various other options you can add in here, but you type that in. And the reason I'd say that is because then you get a file list that's in a text format that has all of those things that you can then import into Excel and quite easily split up into the fields that will, here are the instructions, that will match the spreadsheet that you have to fill out to upload those images into Bold. Yeah. So you fill that out. You zip them all together, zip all the images and the spreadsheet together in a folder, and you chunk it into Bold, and instantaneously it unzips it and sticks it with all your records, which is quite nice. That's cool. So switching to a little bit of reference library curation stuff here. As I mentioned earlier, and I don't want to labor it too much, it's a workbench, not a reference library. There are varied levels of taxonomy in there. There are varied levels, qualities of identifications in there. We know that. As part of the BGE project, here are our islands in the stream, as it were. I'll talk a little bit about the gap analysis stuff that we've been doing to figure out what the gaps are in the European animal list, at least, and then a little bit about the reference library curation. And of course, those two things interact heavily because the more we clean the reference library, the more gaps we find or fix, basically. So I shout out to Fabian from SNSB, who's done the vast majority of the work on this. In essence, looking at the animals of Europe from these various source databases. I don't think this is extensive, exhaustive, but in essence, he took all of the names for all the animals in there. He shoved them together. He did a lot of massaging. There were about 500,000 names processed, which was a bunch of misspellings in each of the databases, actual synonyms, and everything else, and came up with 150,000 valid species names for the animals of Europe, of the boundaries of what we're using for BGE at least. And then the process is now going through some expert validation. So partners in the project said, oh, I'm happy to validate the caddisflies, for example. I'm going to go through that list and double check that you got everything right. Yeah, this is a terrible example. I didn't do that. Anyway, and that was then queried against what's in Bold, because he downloaded the whole Bold data set, and I think this was it wasn't including the private data, but at least we had an understanding of what species had private data in Bold. And it's online with these lovely beetles. And it is the world's slowest website to load, but that's because it's got these massive tables that have to load, and we're figuring out how to make that faster. We are seeking feedback currently, so please go there, have a look, tell us what else you'd like to see in here. So for example, country is missing from here. It would be nice to see that, oh, there are 3 records of that species and they're from these countries, and we're happy with that, you know. If you search in here, just an FYI, if you search in here, when you start typing, your computer will go away for a while and think about things, and then the words will magically appear. So don't think it's broken, just have a bit of patience while we make it faster. You can then export whatever you've searched. So say you search in here, it'll search across all of these fields. So just be aware of that. If you're using a species name, it will come up if the species name is used in multiple genera, for example. And you can download it as an Excel, you can print it, and CSVs. And that's really handy. When you are gap filling, we are going to try and make sure that this list is as up to date as possible by harvesting the records that are put into bold. So even if you haven't sequenced something yet, if you have put a specimen record into bold as part of the BGE project or other projects, we will try and make sure that that is visible here so that we stop duplicating effort, because I'm going to be pulling museum legs off caddisflies and someone's going to be catching caddisflies in the field, and I'm currently pulling legs off Greek caddisflies, for example, and you might go and catch a caddisfly, and we should probably not waste all of our resources sequencing that multiple times. So this will be the one-stop shop for us to try and make sure that people are aware of the most up-to-date gap list. And so you can go there and pick some targets, get that data into bold quickly so that this updates and no one else duplicates effort. That was a very long way of saying, please just use the list. And then switching on to the curation side of things, again, Fabian and Stefan from SNSB. In essence, the goal of this task is to assess the status quo of the existing data in bold, to identify and correct as many inconsistencies as we can and feed that data back to bold so that it goes and gets fixed there and we don't have to do that again. And then to rate species entries according to some sort of quality programmatically, and then for low quality sequences, get the human in the loop to try and curate these things. And also try and suck up as much additional metadata from NCBI and places like that if we can find those records in there. And then generate this public curated reference library, which is a data package that you can download, but it's also a data set on bold that you can query against. Yeah. So some criteria for the reference library is it has to be public. It needs to be versioned so that we can go back in time and compare our analyses. It needs to have transparent curation criteria so that we can all argue about them. It needs to be linked back to the source data by some sort of stable identifiers. It needs to be fixed at the source where possible, and it needs to be fair, which is findable, accessible, interoperable, and reproducible. So not in the notes field. We didn't want to reinvent the wheel, so these wonderful people listed over here published a paper using BAGS, which is a barcode audit grading system. And in essence, it runs all the bins through various decisions, and it comes up with different grades for them. So grade A, we love them. They have more than 10 specimens in them, and they are all in one bin. A bin, for those of you who might not know, is a cluster in bold that sort of is analogous to a species some of the time. So, but one bin is good. If one name is in one bin, that's cool. That makes things easy. B is there's fewer than 10 specimens, but it's still in one bin, so we're not unhappy about that. C is there is a species that has multiple bins. Now, there are many good reasons why a species may have multiple bins. If it has a wide different geographic range, for example, and a lot of phylogenetic diversity within one species, phylogeographic diversity, sorry, then it can have multiple bins. We're happy about that. But we should probably still check them, because it's also potentially cryptic species hiding in there, misidentifications, those sorts of things. Grade D is there are fewer than 3 specimens. It's not the end of the world, but it would be nicer if there were multiple independently morphologically identified specimens for each species. That helps make a robust reference library. And grade E is bin sharing, which is does species X share a bin with other species? So you've got a bin and it's got multiple names in it, basically. And we need to figure out, are those misidentifications? Is that a case, a valid case where the barcode cannot distinguish these two species? Those sorts of things. But what we want to do is just, well, eventually we want these tags or something analogous to them to be within bold so that they're doing the heavy lifting on all of this. But at the moment, what we're doing is we're going to run the data through this pipeline, get all of those tags, and then hopefully feed that back to them with the world's largest spreadsheet and just say, can you please just add the following tags? There will also be additional tags. We haven't really figured that out yet, but it won't just be, this is a BAGS grade E. There'll also be additional tags that we want to add. So this is the BGE approach in essence, but we're not reinventing the wheel here. We're using that, but all we're doing is we're adding a step beforehand where the bold data goes through Fabian's 500,000 names species list to try and fix some of the synonyms. That data goes back to bold so that we don't have to do that too often. And then once that's gone through, it goes through blah, 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 blah. We get all those exciting things. Grade D, insufficient data, priority for us to sequence, which is good. Multiple bins or a bin with multiple names in it goes to, hey, humans, can you go look at that? Here's a table with all the records. Here's a tree that we've made of the records that are relevant to that issue. And here are all the photos from bold. Can you just go and quickly cast an eye over that and go, oh yeah, no, look, that butterfly's blue and those ones are black. Delete it or flag it or whatever for removal. And then once it's gone through that process, it joins all the beautiful grade A's and B's in a curated reference library. Super simple, right? Anyway. So Fabian and Stefan did this analysis where they took the 150,000 species names we have, and it turns out that around 63,000 of them have records in bold, which is pretty cool, and that's 1.5 million sequences, which is good. Species with bins is only 48,500 species have a bin. Don't ask me too many questions about this section. I get a bit confused. But there are quite a few bins. And what they did initially was, because bold has absorbed a lot of GenBank information, they said, well, what if we just threw away all the GenBank info? Let's just do that and see what happens. That's a lot of info. So if we just look at the records that are only on bold and it does not include anything from the NCBI, we suddenly lose 500,000 records, and our number of species with bins drops by 12,000 species. So our number of species without a bin goes up, funnily enough, by about 10 to 12,000 species. And so basically our gap list gets 12,000 species greater if we just delete the GenBank data. So that is not a good way of doing things. As we were just talking about, and Glenn had a very good point, it's like the older records on GenBank, when it cost a fortune to do sequencing, there was probably quite a bit of effort in the identification of those specimens before they were sequenced. Not like now, we're just like, meh, whatever, sequence it, you know? So we're not going to throw them away. We just wanted to see what that kind of looked like, because there are metadata issues with that, with those records. And if we just look at how those things grade, all those 1.5 million grade up against the bags grades, we've got 7,000, so this is now 7,900 species where we're happy they've got a grade A, and 9,000 where they're a grade B. So that's cool. That's quite a few species we probably don't need to look at too badly. There are 10,000 where there's bin sharing. That's not good. That's a lot of manual curation that's going to be needed there. There are 12,000 with less than 3 specimens. So when we're doing our gap filling, we're prioritizing species that don't have any records, and we're aiming to sequence 3 records of each species. So if it doesn't have a record, we go for that one first. However, we're also going for the species that have less than 3 to bump them up, and to bump them up geographically. So we, at least what we're doing it right now at the NHM, is we say, oh, there's only 1 record for this species. Oh, it's from Greece. That species also occurs in these other countries. Oh, look, our collection has 2 from those other countries. Let's skim those, yeah? But yeah, in essence, there's a lot of work to be done in the bin sharing section. And then there's more than 3 specimens and multiple bins. That's also an interesting place for people to look at some point because of the reasons I mentioned about cryptic species and things like that. Yeah. And that's it for me. Any questions? Roya.
The approach that you showed, I mean, is it specifically developed for BGE?
The bags one? No, that was before us. But they have it on a web server where you have to like take the data from bold physically and put it in there, and then they'll run it and give you a report. What we're doing is trying to automate it so that it happens quite frequently, and then add in the manual curation steps and the data going back to bold so that we can actually get as much of that functionality shoved into bold as possible. Because for BGE, we're obviously developing it for the EU or for the European, whatever. But that functionality would have global benefits if we could stick it in there. Everyone wants this, you know, so it makes no sense to keep it separate.
So even we didn't customize it, so we just use something that is already exists.
We use Perl scripts that Fabian has written based on those concepts. Yeah. But yeah. And we're gonna where they just have like those grades A, B, C, D, E. They are we might, if we want to make it complicated, have some sort of subgrading system within an E, like this one we're actually happy about, so it's an E1 or something like that, you know, and so that we can further subdivide it. And the idea is that that happens automatically on computer, and we just deal with the ones where we know we need a human to look at the records. Yeah. You just want me to start reporting, don't you? I can hear what's going on here. I might show you. Let's just see if my my web page, if I'm on the right one. Yeah, look at this. Roya, look. That says part A. Look, it's open. I haven't started writing in it, and there's part B. It's also open.
Oh, I'm so happy, actually. You made some progress.
Well, I opened it. I mean, if you call that progress, I guess you've got to start somewhere.
That's good enough.
Good. And actually, while we're on here, these are all the matches for all of the specimens, the last 15. And that's not a good story. I don't know what's going on here. Oh, we got a human. Hey. Homo sapiens. We got Hylie's euphorbiae. What's that? Anyone? No? Okie doke. Well, we can go look at it. Sorry. Cool. So this one this is the one that said no match, but that's because the match similarity is too low. But look, there are. I mean, it's probably in that genus. I don't know why it's saying no match. Of course, yeah. They are orthoptera, yeah. But I mean, there are quite a few species in here, right? So there's Bimucronata, Tyrannica, Schmidti, Schmerniensis. That's cool. And they all have very similar hit values. But I don't know why. I mean, they're all Tetragoneids. So why is it not telling us that it's the family Tetragoneidae? You know, I mean, unless if we, sorry, I can look here. Unless if we look at like top 100, and maybe, no, that's not going to work. Okay. So yeah, those are the no matches. But if we go all the way to the bottom, beep, 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 beep. That's a sphingered moth. The what? Did you just Google that, or you know that?
I Googled it, but then it makes sense if you...
Yeah. There we go. So that's quite cool. And the other no matches are, just some issue. Yeah. But I've done the other ones, so when they finally download to my computer, I will email around what we've got. Or you can do it. You have all the data yourself. Yeah. So, yeah. And then just to flag, because I love talking in public, that I realize my whiteboard skills need development. So I have made these and put them in the Slack on the differences between regular PCR, indexing PCR 1-step, and indexing PCR 2-step. I'm not going to talk about them now, but just they're in the Slack. Yeah. Anyway, that's me. Oh, sorry, Rob. Yeah, of course. Oh, of course I can. This slide? No, hang on, it's coming. That slide.
No, the last official one.
Oh, God. No, that's even worse. Yeah, that one.
So, what happens if you've got 3? It's not in the code. I saw that too, but I didn't want to...
Yeah. It's less than 3. Yeah, so it's if it's a D if it's less than 3. If there's 3 or more, it's not a D. C is more than 3 or more. 3 or more. Sorry. Yeah. I didn't write the code, thank God. So no. Yeah, it's 3 or more.
Between equals, you get the worst. If there is C and D simultaneously, you get the D.
If there's a C or D, no, hang on. D is only less than 3 specimens.
But if you have
But it's
that belong to multiple Ds, both of them, then you have C and well, no, you can't because it cannot be C because it doesn't have more than 3 specimens.
Yeah.
Okay.
Yeah. Yeah. I think I know what you mean, but I'm not going to answer that publicly.
Okay.
Yeah. It makes sense.
Are these data captured by both from NCBI or they are
These ones, the width.
combination?
Yeah, they're the records in bold that are flagged as NCBI. So what we haven't done is looked at the records in NCBI that haven't gone to bold, and there are lots of those. So that is an additional step. Yeah. So I 100% agree with you, or even more, that it should be acknowledged. We were just talking about that in the break, about with the BGE project, we have lots of curators and people tissue sampling and all these other things that result in genome skim data where there's no authorship, there's no nothing, right? But we also, if we're going to do that, we have to do it properly and do it in an automated fashion because we're not going to manually write 30,000 papers about the 30,000 records we're producing. So I agree, we do need to figure that out properly. And to take that and extend it a little bit, we're all doing this for free, essentially, building the reference libraries, and then there's a lot of commercial companies that are querying those reference libraries and making money off the identifications. We need to close that loop. There needs to be, I'm not suggesting we charge for access to these things because we're all in support of open data, but if you are making money off the data, there needs to be a way to help generate more data, right? Because it improves their product as well. If the reference library is more full, they can sell their product better. Yeah. So we could do that for sure. And I love that. So the Natural History Museum recently published a paper where they looked at the use of GBIF records from the NHM, and they showed that a Natural History Museum London specimen record is downloaded from GBIF every 2.3 seconds or something like that, and that our records are cited 20 times, around about, more than the average record citation on GBIF. And so we were able to turn that around and say, look at the value of digitizing museum specimens. This is bringing massive value to, and we also looked at all the countries that are citing that data and showing that it's helping researchers and all these other, and then flipping it and saying, so now we need more funding to digitize because we are proving that it actually is of great benefit to the world, as it were. We need to do the same for barcode records, or for sequence records in specifically, yeah. And I think Pensoft just released something called a micro publication, which it was on Twitter, so I read that and I was like, cool, that's cool, and then I'm never going to read the paper. But in essence, it's the smallest thing, the smallest unit of science. You can talk about it.
So there's the micro publication, there's also a nano publication.
Oh, a nano publication.
Which is an assertion.
So yeah, as Darwin Tree of Life has dealt with it, by every genome gets published as a genome note paper, and everyone involved is an author on that paper. The collector is the first author, unless other agreements have been made. The identifier is the second author. Then it just goes down the chain of custody of that specimen all the way. So I'm technically an author on 400 or 500 genome notes. I'm first author on a few of them, and those are the ones that go into my CV, but the rest of them will eventually be on my ORCID somehow. Yeah. But just before we close, going back to your comment about the taxonomists being replaced, absolutely, I understand where that's coming from. My view is that if a species has a name, we should let the machines identify future specimens. We should be focusing the taxonomists on describing the 80% of the biodiversity we haven't described yet. And stop wasting our time down a microscope identifying something that already has a name.